Hello guys, my name is Krish Nayak and welcome to my YouTube channel. So guys, in this specific video, we are going to discuss about an amazing end-to-end Langchain project. The project name is Web-based Loader RAG application using DataStax DB along with Groq inferencing engine. Now, many people say that, hey, Krish, we have a low configuration system. Using an LLM model and quickly getting a response is definitely a challenge for us. So for this, we'll be using Groq inferencing engine, where you'll be able to use open source LLM models. Along with this, you'll also be see how we can use DataStax DB as in the form of a vector database and try to query any kind of data and probably get a response. So all these things we are going to discuss in this specific video, and this project will be definitely helpful. You can write this about this particular projects in your resume. In interview, you may probably get a lot of questions related to it. So quickly, let me go ahead and share my screen. And first of all, we will try to understand what exactly is the architecture. Okay. As I said, our project name is Web-based Loader RAG application. That basically means the first thing that we have is a website. From this website, we will try to load the data. Okay, whatever website data it is present over here, we will try to load the data using a library which is called as Web-based Loader. Okay, so this specific library we will be using Web-based Loader, and with the help of this, we will be reading the entire content inside the website. Once we do that, then after that, what we are going to do is that once we get the entire data, we are going to divide this into chunks, right? So that based on the token size or based on the size, we will be able to use it in embedding techniques, right? So here what we are going to do, the entire documents, we are going to convert this into smaller chunks. Once this chunks is there, we will be converting these chunks into vectors. For this, we can use two amazing embedding techniques. One is Ollama embedding and the other one is OpenAI embedding. As I have already told, OpenAI embeddings is very much good when compared to Ollama embedding, but I will try to show you both the way how you can actually perform this specific embedding. Now here, since the website content can be very huge, right? So when we are using this kind of embedding techniques, it may be that we may be having a huge number of vectors. So once we convert this into vectors, we definitely want to store this in some kind of database, right? And this entire thing is basically called as a vector store. So what we are going to do is that we are going to store this in Astra DB. Now this Astra DB, right? It's using a DB, which is just like a Cassandra DB over there, where we will be using this to store our vector data that is present over here, right? After we convert this, then with the help of Cassio, we will be able to connect to this particular Astra DB, and then we will be able to query any kind of data that we specifically have. Now this was mostly with respect to load, transform, embed, and then query. But we will be going more ahead and we will be also understanding how we will be implementing this, because still we have not used Groq inferencing engine. So next step is that we will try to go ahead and use this prompt template. Along with this prompt template, we will be using Groq. Groq provides you open source LLM models, right? For the as an LLM purpose, you can actually use it. You can summarize it along with the prompt template, and then Groq will actually help you to do the inferencing very much quickly. With the help of inferencing, you will be able to quickly get the response, right? Even though you have a low configuration, because this Groq is running in some other cloud, and there you'll be also able to get an API keys. Okay, so amazing thing. And this is based on the recent technique, that is LPU. Okay, in short, it is an inferencing engine which will actually help you to provide quicker response, right? Then we will further go ahead and create retriever chain and use this to get the response. Okay, so this is the entire architecture that we are going to specifically use for this particular project, right? It's amazing, I guess. Okay, and if you find it amazing, please do make sure that you write down something in the comment section. Now let's go ahead and see what are the prerequisites that we will be using, what are the tools that we'll be using. As I said, we are going to use DataStax. Here we are going to use DataStax Astra DB. Okay, so this DB I'll be showing you how we can actually create and how we can actually use. Along with this, we'll also be using this Groq. If you don't know why Groq is used, it is on a mission to set the standard for Gen AI inferencing speed, helping real-time AI application come to life today. So here the technique that is specifically used is nothing but LPU, that is language processing unit inferencing engine. Okay. Now, step by step, we'll go and see that how we can actually implement this. Along with the code, I will try to show you each and everything completely. I will try to write the line by line code so that you can also code along with me, and you can also probably implement so that your learning will be much more better. Okay. So here is my entire folders. Okay. So here I'm not going to use this specific folders because in my Langchain playlist, all these folders are created for different projects. I will click on one more folder and I will go ahead and write Groq. Now inside this Groq, I'm going to create one file. And this file will be, let's say I'm going to write it as groq.ipynb. Okay. Now inside this, I'm going to write down my entire code. Before I go ahead, there are some important libraries that we really need to install. See, Langchain OpenAI, Langchain Core, Python.env, Streamlit, Langchain Community, Langserve. All these are something very important. But along with this, we are going to use Groq, Cassio, and Beautiful Soup, so that we will be able to extract the data from the website. Okay. So all these things we are specifically going to use additionally. Now, first thing first, I will go ahead and quickly install all my requirement.txt file. Okay. So here we are going to write pip install -r requirement.txt. Okay. So once the installation specifically happens over here, then you'll be able to see that all the requirements will be used further in my coding section as I go ahead. Now let's go ahead, and now my requirements is basically installed. I will go ahead and select my kernel, and this is my kernel that is available over here. Now the next step. Okay. First of all, I'm going to import some of the libraries like import OS. Along with this, as I said, we are going to use Groq. So Langchain already has the specific functionalities where it has something called as chat Groq. Okay. So Langchain.groq import chat Groq. So we are going to use chat Groq. Along with this, we are also going to use from Langchain _community. Since we need to load our data from a website. Okay. So here we are going to use .community.document_loader. So here I'm going to basically write document_loader and import web-based loader, right? So we are going to specifically use this because our data source is a kind of website. Okay. Along with this, as I said, we are going to import embeddings. Two embeddings that we are going to specifically use. One is Ollama embedding, and the other one that I am going to use is something called as OpenAI embedding. Okay. So both these embeddings we are going to use. You can use any one of them. If you don't have OpenAI key, then I would suggest go ahead with Ollama embeddings. Okay. Then the next thing that we have is basically we will go ahead and import something called as Cassandra. Okay. Because this Cassandra will be required whenever we are working over there with the AstraDB. Okay. So Langchain, here spelling mistake is there. It's okay. Langchain, here also spelling mistake. Langchain _Groq. Okay, this looks fine. So let's go ahead and execute this. I hope so. So it says from Langchain, no module Langchain _Groq. So we will go ahead and import or do the pip install over here. So I will go to requirement.txt and paste it over here. Because to use the Groq inferencing engine, you definitely require this library. So I will go ahead and open my terminal as usual. And then I will quickly go ahead and write pip install -r requirement.txt. And now you'll be able to see that that library will also get installed, which is basically required over here, so that we'll be able to use the Groq inferencing engine. Okay, so this is done. Perfect. I will close this. Now, if I go ahead and execute it, I think it should be working fine. Now you'll be able to see Langchain _Groq is getting identified, and here you have each and everything. Along with this, I will also import Cassio. Cassio actually is a library which will help you to connect to the AstraDB. So we'll also be using this. Okay. And then one more library we'll try to import is from .env import load _.env, so that we can actually call all our environment variables. So here I'm going to write load _.env, and here I'm going to specifically use this. Okay. Now the next thing is that as you all know, I'm going to use the open source models from Groq, right? So we will go to the Groq website, and here what I will do, I will probably log in inside this. After you log in, you can click on API access. Okay. And once you probably get an API access, so here if you go down, right, all this is the information that you have with respect to API. Okay. And once you probably go ahead and see all the costings, you can clearly see over here. And let's go ahead and probably see the self playground also. Okay. And here you can probably see API option is there. You can go ahead and create the API key. I've already created it long back. I'm going to use this same API key for my calling purpose. Okay. And I've already created an environment variable for the same. Okay. So I will go back over here. Now what I will do, after I have load underscore dot env, I will go over here and I'll open my environment variable. So here you'll be able to see OpenAI API key is there, Langchain API key is there. And don't worry, because if you try to use this, it will be of no use because I'm going to change it. Okay. So don't try to do that. Instead, what I will do over here is that I will also use one Groq API key. Okay. So now quickly, let me go ahead and create this Groq API key. So this is the key that has been generated over here. And the API key name is Groq underscore API underscore key. Okay. So I'm going to save it. And now I will go ahead and call those specific API key over here. Okay. And then here, let me go ahead and write Groq underscore API underscore key is equal to os dot environment. Okay. And here I'm going to basically call my Groq API key with the same name that I have been using. Okay. Done. Then once I use this Groq API key, that basically means I'll be able to use the open source LLM models. But the next thing that I specifically want is my DataStax AstraDB connection details. Okay. So first of all, go ahead and sign in over here. Once you probably sign in, you can sign it with your email or GitHub. You'll be able to see something like this. Okay. Then you can start with creating first of all a token. Okay. Because this token will definitely be getting required. So what you can do, you can probably select what permission you want with respect to this specific token. Let's say administrative user, organization administrator, billing administrator, whatever things are there, right? Like how in AWS we provide the access, and then you can click on generate token. Once you get the generate token, you will be able to see this kind of token ID. Okay. You just need to copy this token ID, and what I will do, I will create my token ID over here. Okay. So here what I will write is that I will create a variable Astra DB underscore application underscore token. Okay. And this will be equal to the token name that I have specifically copied from that website. Okay. So here you'll be able to see that I will paste it over here. Okay. So just let me remove this so that I don't require it. Yeah, perfect. So this is my token ID for accessing the AstraDB databases. The next thing that I specifically required along with this AstraDB application is my AstraDB ID, right? Because I need to create my new database, right? So AstraDB ID, how to create this specific ID? Go ahead and go to the database and then you click on create a database. Okay. Out of this two, serverless vector and serverless non-vector, I will go ahead and probably write this. I will write the DB name, let's say demo Groq. Okay. Then I can select whatever region you want. Okay. And then I will go ahead and create the database. Once this database is probably created, it will take some amount of time. In order to get the database ID, you just need to copy it from here. See this highlighted option over here is the copy database ID. So I've already created it over here. You'll be able to see because it is going to take some amount of time to create that specific database. So I am going to use just this database ID, which I've already created it, and I will go ahead and paste it over here. Okay. So here, let me go ahead and write it. Okay. So this basically becomes my AstraDB ID. So why this AstraDB is basically required? So here is an error saying that Groq API key error os.environment. Okay. I did not write os.environment Groq underscore API key. Let's see. Groq underscore API key. Okay, I have to execute this once again because I had already executed it. Now I think it is working fine. Now this AstraDB ID, why it is used? Because we really need to store our vectors into a vector database, and this AstraDB is nothing but a vector database. Okay, and Groq is specifically used to use the open source LLM models. Okay, now in order to connect to this particular database, that is AstraDB. And just to check, we are going to use Cassio.init, and then we are going to specifically use token AstraDB underscore application token. The second parameter is nothing but my database ID, which I'm going to specifically give, and this will nothing be but data AstraDB ID. Okay. Now, once I execute this, if it works absolutely fine, that basically means you are connected to your databases. Okay. So this connection of the database is specifically done. Okay. So this, I will just go ahead and provide you a comment: connection of the AstraDB. It is taking some amount of time. Let's see how much time it will probably take. So it has taken 18.1 seconds, but it is okay. We are connected to this particular DB. Okay. Now the next step, which is super important, in short, we will be seeing that what all things we can basically do. As I said, we are going to take an HTML page. Okay. So for taking an HTML page, what I'm going to do, I will just go ahead and write Langchain underscore community dot document underscore loaders. I'm going to import document Langchain underscore community dot document underscore loader. I'm going to import web-based loader. Okay. And then along with this, I'm also going to import BS4, right? Beautiful soup 4. So you can see from Langchain import web-based loader, it is giving us an error. Let us see what is the error all about. From Langchain underscore community dot document, it should be document underscore loader. Okay. So once we import all these things, now what we are going to do, we'll take an HTML page and we'll read the data from that specific HTML page. So let me just show you one of the HTML page which I am going to specifically refer so that I can use it as a Q&A chatbot. So this is the website that is there. So here you can see LLM powered autonomous agent, some article with respect to LLM powered autonomous agent. And I'm going to read this entire document altogether. Okay. So how to read it, that is the most important thing, because this in short is an unstructured data, right? So here what I'm going to write, I'm going to create a loader variable, and here I'm going to use web-based loader. The first parameter is basically my web paths. Okay. And here I am going to probably give my web path in the form of tuples, so that, or let me just write down the code for you or copy the code from you. So it will be easy for you to understand. So here you can see web-based loader, web path is basically given this. Now from this particular page, what all information I specifically want. So if you go ahead and see this page and probably do just inspect. Okay. Here you'll be able to see post title. I will definitely be required because that is the information that I want. Post content I definitely require because that will be having the entire content. And what are the important information that you want? You can basically just write the class name. Okay. So similarly, what I am actually doing in this particular code. So now let's proceed and write the code and see like what all text or data we really want from this particular website. So I will go back over here. So here we have used an argument with beautiful soup trainer. And here class that I have specifically written in the form of tuple. I want post title, all the content that is present inside that. I want post content, I want post header. So all these three information that are there in that particular website, I want all those things. And then what I've done is that I've loaded this particular loader in the form of documents. So once we do this, so we will be able to see that we specifically get all the text documents over here. So once we execute this, so these are all your text documents from that entire website. So just imagine how fast this is. And it is so good and amazing to work with the entire unstructured data. Now, after this, the next step that I would like to follow over here is with respect to the character split. Okay. We really need to split our text documents into chunk of documents. So for that, what all things we can specifically use, that we will use recursive character text splitter. So how that is basically available in from Langchain dot text splitter import recursive. So from Langchain dot, okay, spelling mistake is there, dot recursive import recursive character text splitter. And using this particular text splitter, what we are going to do, we are going to convert that entire documents of text, right, into chunks. So here what we are going to do over here is that we are going to initialize recursive text splitter. Here let's say that I am going to use the chunk size. The chunk size is equal to 1000, and along with this I'm going to also use chunk overlap. So this will basically be chunk underscore overlap, and this I will initialize to 20 or 200, whatever it is, up to you. I've used 200, and this will basically be my text splitter variable, and I will use this particular text splitter variable and use this and use split underscore documents and split all my docs or all my text documents that is present over here. Okay, so now text documents is over here, and this is basically my, since we are going to use split documents, so this will basically give my docs. So let's go ahead and see my first 5 docs so that you'll be able to see. So here, yes, I'm able to see all my documents. Perfect. This is mostly about dividing your entire data into chunks. Now the next step is that we have to convert all this data in the form of vectors and store it in our AstraDB. Okay, so here the next step is convert data into vectors, or convert documents into vectors and store in AstraDB. Okay, now how to specifically do this? So first of all, what I will do is that I am going to create my embeddings. Now in the case of embeddings, as I said, I'm going to use OpenAI embedding, or you can also use Ollama embedding. It is up to you. But before that, let me quickly go ahead and see some of the code, because I really want to be efficient, and call my OpenAI API key. Okay. So I will be calling my OpenAI API key over here. Okay. So that OpenAI embeddings can be used and we don't have to even worry about it. Okay. So OpenAI embedding. Now what I'm going to do with the help of this specific embedding, I'm going to store it in my vector database. Okay. So here I'm going to write Astra underscore vector underscore store. And here I'm going to specifically write Cassandra, since we are going to use the Cassandra DB. And here the first parameter that we give is the kind of embedding that we want. So obviously we have created an embedding which is called as OpenAI embedding. It is up to you, whatever embeddings you really want to create, please go ahead and create it. Okay, it is up to you. Again, I'm telling you whether you want to use Ollama or other embeddings. Okay, so I'm also going to give my table name. My table name will specifically be QA underscore mini underscore demo. Okay, I'm just giving some name over here. 2 more parameters. One is with respect to session. So let me go ahead and write session is equal to none, because we are not tracking any session over here. Once this is done, I think we are good to go. This basically becomes my vector store. Okay, table name. Okay, there is some error, so I'm going to create this table name. It should be table name. Okay, no worries. Again, an error. Cassandra key space. Okay, key space is also one more parameter that we require. So key space, here also we are going to keep it as none. Okay, so all these parameters are set up, and this is basically my Astra vector store. So in this particular variable, you'll be able to see that we are going to apply all these embeddings. Now using this vector store, we are going to save it entirely inside the Astra DB database, right? So that is what we are actually looking at, right? We need to take this entire information and store it in our Astra DB database. Okay, so how to do that? So first of all, what I'm going to do is that I'm going to use from Langchain dot indexes dot vector store, and going to import vector store index wrapper. Okay, so we definitely require a wrapper once we probably create a vector. Okay, then we will be using this Astra DB vector store. So Astra vector store, and we, in order to save it in the Astra DB, we will write add documents. Okay, if we are converted into text, we have to use add text, but right now we are going to use add documents. So finally here you can see that as soon as I executed this again of add documents, so here you can probably see that we have inserted 66 headlines. So all the documents has been uploaded, and then we have also created a vector store index wrapper. That basically means if I really want to query from this Astra vector index, I can definitely query with the help of this vector store index wrapper. So first of all, we'll just go ahead and verify whether our data has been uploaded or not, and whether our table has been created or not. So I'm just going to reload this particular page, and I will go to the overview. So here you can see some number of requests has gone. Okay. And with the real time, all the information has been stored itself, right? So this looks absolutely great. And here you can see your table has also got created. Okay. So this is good that we are able to insert the data. Now let's go ahead and query some information from this particular vector store index wrapper. Now this is important because you should really know how to query things, right? How to query what is the information out there and all, right? So I will go again back to that particular page. Okay, website. And let me just go ahead and search for anything. Okay, so let's say chain of thoughts. I'll just search for this. Okay, so I'm going to go over here and let's quickly go ahead and write Astra vector index dot query. So this basically becomes my vector database, right? Vector store itself. So here I'm going to just write my information. Along with this, I'm also going to use my LLM model. And this time my LLM model should be something, right? And now we'll go ahead and initialize our LLM model. Obviously, I really require the LLM model of Chat Groq, as I said. So Chat Groq is what I will be requiring it over here. So Chat Groq. Now, before I go ahead and create Chat Groq, so first of all, you'll be able to see that if I use Chat Groq, right, the first parameter will be nothing but my Groq API key, right? So this Groq API key, we have already written it down over here, and we have stored it in a variable which is called as Groq API key. The environment variable is already created. Okay, so this basically becomes my API key. The next, I will just go ahead and use some model name. So my model name will be specifically over here as Mixtral. Okay, so I'm going to use one version of model that is provided by Chat Groq. One is this one. So quickly, let's go ahead and copy and paste it. So I've done it over here. So Mistral 8x7 BM model I'm specifically using. I'll initialize this to my LLM. Okay. And obviously when we are creating an Q&A application, it is always better that we create our own prompt template, right? So for this again, we'll be requiring chat prompt template. So let's go ahead and initialize this chat prompt template from where it is specifically coming. It is very much simple. Here I'm going to go ahead and write from Langchain dot Langchain underscore core dot prompts. I'm going to import chat prompt template. Okay. So this chat prompt template I'm specifically going to use, and here is my entire thing. I have just given a simple prompt: answer the following question based only on the provided context. Think step by step before providing a detailed answer. I'm also saying that, hey, I will tip you some virtual currency, let's say $1,000 if the user finds the answer helpful. And then the context is over here and the input is over here, whatever input I'm specifically giving. And I will go ahead and execute this. Now, if I want to use this information and query, so I can use Astra vector index query and chain of thoughts. I've given some information with this LLM. Let's see what kind of output I will be able to get. Okay. So here you can see I'm getting the output completely over here, which is really, really amazing because now this has become a Q&A chatbot, right? From the vector store, we can search for anything. So chain of thought is a prompt technique. All the information is probably coming over here, right? So this is really, really good. But we will not stop here. Further ahead, what we are going to do is that we are going to create our stuff document chain, which I've already discussed in my previous video. So from Langchain dot chains, spelling, okay, Langchain dot chains, and then we are going to probably write import. Two things we are going to do. One is the create retrieval chain. I'm going to create a create retrieval chain, and the next one from Langchain dot we are going to use the create stuff document chain also. So I'm going to write chains dot combine documents, so that we'll be able to combine it. And I hope everybody knows the importance of this because we have discussed this in our previous video, right? So dot combine, and here I'm going to basically write underscore documents, import create stuff document chain. Okay, so this two specifically we are going to use. One is definitely for the retriever and the other one is basically for the chain itself. Okay, so that we can actually combine both of them and automatically we'll be able to use this. Now we know already we know our vector store, right? So Astra vector store, we will try to convert this into a retriever. So as a retriever, I will specifically write so that it acts as a retriever, and this retriever I'll create it as a variable. Now the best thing about this retriever is that this retriever along with our stuff document chain, we can combine them. Okay, so quickly let's go ahead and write create stuff document chain, and here we know what all things will be required. One is LLM and the other one is prompt, right? So once we do the combination of this, then we specifically get our document chain. Like what is the steps, step by step, what it is going to do, right? It is going to probably combine this LLM with the specific prompt. Okay, now retriever plus document, when we probably join them, then that actually is used to create our create retrieval chain. So in short, what we are going to do is that I'm going to write retriever comma document chain. Okay, now the reason why I'm doing this is that so that finally we'll be able to see our retrieval chain. So retrieval underscore chain, and now we can query anything that we specifically want. Okay, now how to query over here? It's very simple, by using invoke. So I'm going to use retrieval underscore chain dot invoke, and inside this invoke I'm going to basically use a parameter which is called as input. Okay, input, because this is the key that we specifically need to give. Okay, and the input will be what? Let's say I'm going to give this chain of thoughts. Okay, whatever is the data that we have already searched. Okay, now along with this, what all things you specifically required, that is what you're going to basically use this invoke, and then you finally get the response over here, right? And finally, let's go ahead and see the response. This is invalid syntax. Perfect. But I think you'll be able to get this, right? So finally, this, you can see the answer is over here. Context, document, everything, information is probably over here. So here, if you really want to get an answer out of it, so this is nothing but response of answer. Okay, so this is their final output. Now this is the best thing that you can probably see, like how we have combined this entire architecture along with each and everything. I've written the code, everything in front of you, which is quite amazing, and we have finally implemented these things. So I hope you like this specific video. I hope you're able to understand about each and everything with respect to DataStax, with respect to Groq inferencing engine, and you can see how quickly the response is, because here we are going to use the LLM model as an open source. Inferencing engine is used, LPU, language processing unit, is specifically used. So I hope you like this particular video. This was it for my side. I'll see you all in the next video. Have a great day. Thank you and all. Take care. Bye bye.